Hi everyone. In today's lesson, we're going to be looking at composition of functions, which is something we've previously done, but this time we're going to include some trigonometric functions with it. And all of the problems in today's lesson have been pulled from the official IB exam question bank. So this is really good practice. So the first question, we have functions f and g, and we're asked to show that g of f of x equals 2x plus 11. So whenever we see a show question, it's basically like a little proof. We know what the answer is. We're just trying to prove that we know how to get to that answer. All right, so I'm going to rewrite this. I'm going to write this as g of f of x. And that just tells me that f of x is going to be input into the g function. So the g function is the lead function. And I like to put a box wherever there's an x in the g function. And that just tells me now that the f of x function is the inside function. Wherever there was an x in the g function, we're going to replace it with the f function. And now we just have to simplify that. All right, 4 goes into 8 2 times. Distribute the 2. And then add the 6 and the 5. So g of f of x is equal to 2x plus 11. We've proved it. All right, question number 2. Consider a function f, and we have the function, and we want to find the period. Well, we know that this is a sine function, and we know to find the period of the sine function, it's going to be 2 pi over b. The value right here is b. The value in front of the x or theta or whatever they're calling the angle for the function. So in this case, it's going to be 2 pi all divided by pi over 6. When we divide by a fraction, we multiply by the reciprocal. So the period of this function is 12. Part B, the function has a local maximum at the point 2, 21.8, and a minimum at 8, 10.2. Find the value of C. All right, so we can take our point, either point, and we can put it into our function, and we can find the value of C. I'm going to pick the first point. So this is my x, and this is my y. So for this function, let me rewrite the function here. F of x would be the y part of the coordinate, so I have 21.8 equals 5.8, the sine of pi divided by 6, and we're going to input into the x part the 2, so 2 plus 1 here, plus c. Well, the sine at pi over 2, this is pi over 2, the coordinate there is 0, 1. The sine is the second part of the coordinate, so the sine of pi over 2 is just 1. So we end up with 21.8 equals 5.8 times 1, or just 5.8, plus c. So 21.8 minus 5.8 is going to give me 16, so 16 is equal to c. Hence, find the value of f of 6. So same function, we're going to rewrite it. We're going to replace the value of c, though, with what we found to be 16. And they want us to find f of 6. And we can put this into our calculator and solve. Now just be careful, we don't see a degree symbol anywhere, so we know that we are in radian mode. We're going to go to mode, and we're going to make sure that radian is highlighted. Then we'll enter in our function and hit enter. You should get a value of 13.1. All right, next page. We have two functions, and we want to find h of x. H of x is equal to f of g of x. So f is the lead function, and g of x will be input into it. So Our lead function is x minus 8. Inside the box goes the input function, which is g of x. G of x is x to the fourth minus 3. So we get x to the fourth minus 11. So h of x is equal to x to the fourth minus 11. Number 4, let f of x equal the given function. X is from the set of all real numbers, right? That's what this piece means here. The range of f is from k through m. Find k and m. All right, so if we think about the sine function, the parent sine function has a center at 0 and an amplitude of 1, so it's going up and down between -1 and 1. Now, this function that we have here, we have a center at 4 because we know that the vertical translation of the function is 4. The amplitude is going to tell us the distance from the center, so we know we're going to go up 2 and we're going to go down 2. So we're going to go up to 6 and we're going to go down to 2. So now we know the range of our function without even doing a big, detailed sketch of this function. We have enough information to determine the range. The range of this function goes between 2 and 6. So k is equal to 2 and m is equal to 6. Now it says let g of x equal 5 times f of 2x. All right, so what does this really mean? This means multiply 5 by the entire f function. And it also means replace x with 2x everywhere in the f function. All right, so let's go ahead and do that. So g of x is going to be equal to 5 times the whole f function. The f function is shown in part A, and we're going to replace x with 2x. So let's write that out. So we have 2 sine 3. The x, I'm going to put a box where the x was in the f function plus 4. And they're asking us, again, to replace this x with 2x. So 2x is going to go inside the box. All right, let's make that look a little nicer. We're going to have g of x equals, now 5 will be distributed to both terms. We're going to multiply 5 by this part and 5 by this part. So 5 times 2 gives me 10. And then inside this sign, I've got 3 times 2x. That's just 6x. And 5 times 4 gives me 20. All right, so I end up with 10 sine 6x plus 20. Part C says the function can be written in the form 10 sine bx plus c. Write down the values of b and c. Write down means that we should just be able to look at our function and know the answer. And we already have our function in the right form, so we have b here, and we have c here. So for letter C, b is equal to 6, and c is equal to 20. Find the period of g. Well, this is a sine function. The period of a sine function is 2 pi over b. We know that b is 6, so the period of this function is pi over 3. And last part, letter E, the equation g of x is equal to 12. It has 2 solutions between pi and 4 pi over 3. Find both solutions, round to the nearest hundredth. So we're going to set g of x equal to 12. We're going to put 12 in y1 and the other side in y2, or vice versa, it doesn't matter, into the calculator. And we'll look between pi and 4 pi over 3, and we'll see where the intersection points occur. All right, we have our equation entered. We're going to go to our window, and we want to look between pi and 4 pi over 3. And we're going to use the pi button. We'll do a scale of 1. Let's go back and look at our function. Our function has a center. The vertical translation is 20, so our center is at 20, and we're going up from 20 and down from 20. So we're going to go to 30, and we're going to go down from 20 at 10. All right, so our minimum value will be 10, and our maximum value will be 30, and we can leave the y-scale at 1. Hit graph. We have 2 intersection points. We have one here and one here, so we have to calculate those intersection points. Second trace, number 5. Move your little spider nearest to the intersection point you want to find first. That should be good enough. Enter, enter, enter. We get a value of 3.82, rounded to the nearest hundredth. Do it again. Second trace, number 5. Again, move close to the intersection you want to find. Enter, enter, enter. And the other value is 4.03. It says let f of x equal 1 plus e to the negative x, and g of x is 2x plus b, where x is the set of all real numbers and b is a constant. Find g of f of x. So g is going to be the lead function. Put a box wherever we have x in our lead function, and then inside the box we're going to replace with what we know is the f function. And that's it. Part A is done. Let g of f of x equal 6 and x equals 0. Find b. All right, so g of f of x we know is, let's just rewrite it here. So g of f of x is equal to 6 and x is equal to 0. Negative 0 just means it's 0. 0 doesn't have a sign. It's neither positive nor negative. Anything to the 0 power is 1. So we end up with 6 equals 2 times 2. So our final answer here is b equals 2. All right, we have an f function, and they're asking us to show that if we input 2 pi into the function, we'll end up with just 2 pi. Seems a little hard to believe, but we'll try it. Anywhere in the f function where we have an x, we are going to replace it with 2 pi. All right, we end up with, and you have to know your unit circle here. Here's 3 pi over 2. The coordinate at 3 pi over 2 is 0, negative 1. The sign is the second part of the coordinate, so we know that the sign of 3 pi over 2 is negative 1. So we get 2 pi plus a times negative 1 plus a. That's 2 pi minus a plus a. Ooh, so we end up with just 2 pi. So f of 2 pi is equal to 2 pi. Check. Number 7, new problem. We're being asked to express x squared plus 4x minus 2 in the given form. Whenever we have to change forms like this, we know that we're going to go back to our friend complete the square. And I know for a fact that IB does like problems where you have to change forms and use complete the square. We find the complete the square value by doing b divided by 2 squared. So for this problem, the value of b is right here. That's a 4. So we're going to end up with 4 divided by 2 squared, which is 2 squared, which is 4. So our complete the square number for this expression is 4. So the way I usually teach it is I say leave a placeholder. So we have x squared plus 4x, leave a placeholder, minus 2, leave another placeholder to balance it. So all I've done is I've taken this part and put it here, and this part and put it here, and now I'm going to use my complete the square number. So Plus 4 is my complete the square number, but I can't just add 4 to an expression. It changes it entirely. I have to balance it by putting a minus 4. Now, this part of the expression can be rewritten as a square. It's going to be rewritten as x plus 2 squared. X plus 2 times x plus 2 will bring me back to x squared plus 4x plus 4. And then minus 2 minus 4 is minus 6. So I have now changed my form from standard form of a quadratic into the vertex form. So x plus 2 squared minus 6 is my answer for part A. It says let f of x equal x plus 2 and g of f of x is equal to x squared plus 4x minus 2. Write down g of x. Okay. So we know that we just figured out in part A that this is equal to this. All right, so let's write that down instead. So we've got g of f of x is equal to x plus 2 squared minus 6. And so the question is, where in this function would x plus 2 fit in? Well, here's x plus 2 right here. So the g function, if we kind of work backwards, the g function must have been equal to x squared minus 6, right? Because if I replaced x in my g function with f of x, which is x plus 2, that makes sense when we go this way. Now that one was a little hard. I have to admit, I don't know that I could just have looked at this and known. I may have had to think about that for a minute or two, but remember, IB always uses parts from the previous parts in the problem to help you solve the next part. So always use the previous part as a clue as what to do. We have f of x and g of x, and we want to show that f of g of x is equal to the given function. So this guy should be pretty easy. We're going to input g of x. F is our lead function, so we're going to put a box wherever we have an x in the f function, and we're going to put g inside the box. So this becomes x squared minus 2, x squared minus 2, all minus 1. So when we FOIL that, we get x to the 4th minus 4x squared plus 4 minus 1, which is equal to x to the 4th minus 4x squared plus 3. So we did our show, we proved it. On the following grid, we're going to sketch the graph of f of g of x. So from part A, we're going to use x to the 4th minus 4x squared plus 3. So for this problem, we want to make a table of values. And we know for sure that we're going to want to include the lower bound, and we're going to want to include the upper bound. All right, so let's go ahead and put this into the calculator. We're going to go to y equals, clear out what's there. And we want to go to our window, and we want to set our x minimum should be at 0. Our maximum should be 2.25. But we're really not sure what the scale should be for the y min and max, so we're going to start with -10 and 10 and a scale of 1. Let's start there. Okay, great. So we do see here that we have a minimum value, so we know that we want to include that in our table of values when we do our sketch. And it looks like we also have 2 0 values. So this is a key. So we have the beginning of the graph and the end of the graph we know we want to include. And then we have a 0 here, a 0 here, and we have a minimum. All those values we want to include. So let's find the minimum first. We're going to go to second trace, number 3. And then we just want to be a little to the left of the minimum. Hit enter. A little to the right of the minimum. Hit enter, hit enter. So we know we have a minimum value at 1.41, -1. And then we also have some zeros, so second trace number 2. I'm going to move a little to the left of the 0, which is a little bit above it. Hit enter. To the right is a little bit below it. Hit enter, hit enter. And we get a value of 1, 0. So we also want to sketch that in our graph. And then let's find the other 0, second trace, number 2. Move our little spider over to the other one. This time to the left of the 0 is below the 0. Hit enter. To the right is going to be a little above. Hit enter, and we get 1.730. So I'm going to go to second window for table set, and I'm going to set it at 0. So let's look at the table now. Okay, so I have I'm crossing the y-axis at 3. And I also want to look up what is my value for 2.25. So I can set my table to just take me right to 2.25. And then second graph to get back there, and I get a value of 8.38. All right, so I have all those values in my table. I'm going to plot all those values, sketch the graph. And now I have a beautiful graph ready to go for part C. The equation f of g of x equals k has exactly 2 solutions. Find the possible values of k. All right, this sounds a little intimidating, but all this means is, where can I draw a line? So k is just y equals k. Y equals k is just going to be a line. So where in this equation can I draw a line where I'm going to hit the equation in 2 places? Right, you can see all of these places. I'm going to hit it in 2 places. So between 3, right? But if I hit right at the minimum, that's only 1 place, so it's going to have to be greater than the minimum, and our minimum value happens at -1. So I know that k is going to be greater than -1, but less than or equal to 3. All right, that's all I have for this lesson. Thanks for watching.